Hi, my name is Martin, and in the roughly next 10 minutes I want to show you how you can use Hugging Face spaces in order to deploy machine learning demos using CI/CD, meaning in an automated way. In the past roughly 4 years, next to job and studies, I've been working on a machine learning feature for an open source project, and it really escalated in scope and time and everything, but I learned a lot during that time. And what I've discovered is that there's a lot of room for usability improvements in open source software by introducing machine learning features. Normally these features are exclusive to commercial software because they are simply very complicated to create. And over the last 4 years, I've learned a lot of details and strategies to bring these open source machine learning features into life, and that's what I want to share here. Today, we want to tackle the problem of having a machine learning model that lives on your computer. You've done all the training, all the data curation, and you have it running on localhost, but the moment that your colleague or friend asks for a link to try it out, the whole system collapses. So today we want to look into how can we create a demo using Hugging Face spaces in an automated way so that you do not have to deploy the model over and over again in a manual way. We will do that using CI/CD. Speaking of CI/CD, CI/CD stands for continuous integration and continuous deployment or delivery, and is really simply an automation. An automation that triggers a task given an event. The event could be, for example, whenever someone pushes code into a code base on Git or GitHub, or whenever a merge request or pull request is integrated. The task that is done is, for example, linting the code in order to keep code quality high, or creating the newest documentation about it. Here we want to use it in order to deploy a new version of your machine learning model into an app so that people can actually use it. In the next few minutes, I want to first start with a very short blog about the concepts on how to structure your code to make it work, and then we have a look into the code. Let's start with the architecture first. Okay, everything begins locally. We assume that you have built your machine learning model. It sits on your disk and it works. Now, in order to make progress, you build and test your application locally using Docker. For example, you could build it using Streamlit or Gradio or whatever other framework you want. In order for the whole setup to work, you need 3 files. The first one is a README that is specific to the format of Hugging Face. The second is a Dockerfile because we want to use Docker for that. And the third one is a file that is called GitHub Actions Workflow. GitHub Actions is the CI/CD product of GitHub, and workflow stands for one of these automations. When you now push your code into GitHub, because you have committed a change, for example, GitHub now interacts with Hugging Face. The GitHub Actions, so the automation, pulls the Hugging Face as a repository, because the one thing that you have to keep in mind is that every Hugging Face space is literally simply a Git repository under the hood. So the GitHub action pulls that Git repository and updates the code for your application, for example, UI changes or model changes or whatever it might be, and then it pushes it back into Hugging Face. Hugging Face now understands, the space has been updated, so I have to rebuild. It looks at the Hugging Face-specific README file that I mentioned earlier and the Docker file and rebuilds the whole space in maybe 5 minutes. And with that, your application, the updated one, is now live in a fully automated way. After setting this up, maybe takes, let's say, half an hour or an hour. Everything from now on is automated. What do you have to implement in your repository to make that work? The way that I do it in my hobby project is that I take a Hugging Face-specific README and copy it over the existing README, because the README in Hugging Face is really what configures the whole deployment. When then GitHub pushes it back into Hugging Face, the Docker space to be precise, it checks the README first and sees, okay, the person wants to set up a Docker space, it wants to expose it on that code, on that port, and it wants to call it that particular name. It then uses the Dockerfile in order to rebuild the image and deploys it. With that, we have seen some concept and some theory, quote unquote, so we will have a look into, first of all, the code. I mentioned the 3 required files that you have to have. It's a Hugging Face-specific README, a Dockerfile, and a workflow file. I'll open them up now one by one, and we have a look. So here we see the Hugging Face-specific README file. This is the Dockerfile, and inside the .github workflows folder, we can see in this particular example now 4 workflows, but we are only interested in the one that pushes or updates the Hugging Face space, this one here. How does the README look like? The README is a markdown file. There's no content in the README except for what is called front matter. It's essentially metadata. Here you define the name of the space, the emoji, the color. You define what technology you want to use to deploy it. Docker is selected here for its flexibility because it also allows you to test it locally. And then the app port that you want to expose. The Docker file that is used is a regular Docker file here now for Python. It installs a bunch of dependencies, then copies the code in, installs the code inside the Docker image, and then runs the command, runs the web app, literally. I'm using a Gradio app here because it's very easy and nice to deploy, and the Docker deployment really gives the full set of flexibility. Lastly, all of that does nothing if there's no workflow, no CI/CD workflow to trigger it and to perform these steps. Essentially move it over on the GitHub, on the Hugging Face side in order to make it work. This particular workflow here has now 4 steps. The first one is to check out the code. Again, install a bunch of dependencies, and now comes the important part. It clones the code from Hugging Face into the CI/CD workspace in order to then copy the updated code into that repository and then commit it back into Hugging Face. Here we can see the push command, and with that it is pushed into Hugging Face. Okay, now let's look at how the demo actually looks like. So the demo allows the users to use the machine learning model under the hood without any installation. So it's really a convenience feature, and it allows me to collect data if people sign up for it. It is a rich document, for example, allowing you to add some videos for explanation of what people can see, and then they can interact with the whole system. But the interesting bit is really living here in the Files tab, where we see a full replication of the code base on GitHub, but in a fully automated way. So it is copied to there completely automatic. And whenever the the Hugging Face space detects a change, it looks at that README here. This is now the Hugging Face specific one, sees the configuration and sets up the space accordingly. I am, for example, using a Docker space so that the Docker file is used, for example. And after rebuilding the whole system, it takes maybe 5 minutes, the new version of the application is live, which is great. With that, we have solved now the problem of you having your models only locally, because you can push them now in an automated way to Hugging Face spaces for you to share with your friends and peers. I have now 2 more links for you. The first one is for the example file that I use in my own repository. You can take it, steal it, and get inspired by it for your own projects. And there's a second link in the description where I give the same information that I've now shared, but in a written form on my blog, just in case you're more of a written person. With that, thank you for your attention. If you have any questions, please leave them in the comments. I'm very happy to answer to any of them. And if you have some ideas about videos, for example, also let me know. I'm super eager to record a few more videos in order to share the message on how to bring machine learning features to the open source world, really. With that, thank you for your attention and see you in the next one. Bye bye.